Hello everyone, today I'll explain you this question. So let's start. Write the equation of the straight line parallel to the line 4x minus 6y minus 3 equals to 0 and 2x minus 3y plus 7 equals to 0 and passing the midway between them. Let two straight lines be given in the plane and call these straight lines as A and B. And assume that the equation of the first straight line is 4x minus 6y minus 3 equals to 0, and respectively the equation of the second one is 2x minus 3y plus 7 equals to 0. Take an arbitrary point m0 between these straight lines whose coordinates are equal to x0 and y0, and assume that the distance between this point and the straight lines are equal. Draw a straight line passing through this point and parallel to the given straight lines. Call this straight line as C. According to the condition of the question, we must find the equation of the straight line C. And in this example, we use the formula for finding the distance between the point and the straight line, which is given by its general equation. Let's assume that the straight line be given by its general equation as ax plus by plus c equals to 0, and the arbitrary point m0 whose coordinates are equal to x0 and y0 is given. So the distance between this point and the straight line will be equal to module ax0 plus by0 plus c over square root a square plus b square. So let's use this formula. The distance between the point m0 and the straight line a will be equal to module 4x0 minus 6y0 minus 3 over square root 4 square plus 6 square. And respectively, the distance between the point m0 and the straight line b will be equal to module 2x0 minus 3y0 plus 7 over square root 2 square plus 3 square. To solve this equation, firstly, we must simplify the denominator of the first fraction. We can write the square root 4 square plus 6 square as square root 2 square multiplied by 2 square plus 3 square. And this is also can be written as square root 2 square multiplied by 2 square root 2 square plus 3 square. And module 2 square will be equal to 2, and it's equal to 2 times square root 2 square plus 3 square. So let's replace this number in the denominator of the first fraction, and we obtain that module 4x0 minus 6y0 minus 3 over 2 square root 2 square plus 3 square equals to module 2x0 minus 3y0 plus 7 over square root 2 square plus 3 square. And we can reduce square root 2 square plus 3 square both sides of the equation. Or we can say that if we multiply both sides of the equation by square root 2 square plus 3 square, the equation is not changed. Let's multiply both sides of this equation by 2, and we obtain that module 4x0 minus 6y0 minus 3 equal to 2 times module 2x0 minus 3y0 plus 7. and we must simplify this model equation. And to solve this equation, we'll see two cases. In the first case, the sign of the expression under the model is not changed, and in the second one, it is changed. So let's start in the first case. And we write 4x0 minus 6y0 minus 3 equals to 2 times 2x0 minus 3y0 plus 7. Using the distributive law, we obtain that this expression is equal to 4x0 minus 6y0 plus 14. If we move 4x0 and negative 6y0 to the left side of the equation, we obtain that 4x0 minus 6y0 minus 3 minus 4x0 plus 6y0 equals to 14. And we can reduce 4x0 and negative 6y0. So we obtain that negative 3 equals to 14. And we know that this equation is not true. So let's write the second case. In the second case, the sign of the expression under the model is changed, and we obtain that 4x0 minus 6y0 minus 3 equals to negative 2 multiplied by 2x0 minus 3y0 plus 7. And similarly, using the distributive law, we obtain that the right side of this equation is equal to negative 4x0 plus 6y0 minus 14. And if we move the expressions of the right side of the equation to the left side of the equation, we obtain that 4x0 minus 6y0 minus 3 plus 4x0 minus 6y0 plus 14 equals to 0. If we simplify this equation and combine the like terms, we obtain that 8x0 minus 12y0 plus 11 equals to 0. And it is our answer. And it is the equation of the straight line C.